So I'm Matt Iadanza. I'm a computational scientist at CCP-EM, and I'm here today to talk about new tools for the next generation of CCP-EM, which is two pieces of software called CCP-EM Pipeliner and Doppio. So our goal here is to build what we're calling an integrated processing pipeline that can go from raw data coming off the microscope through fully refined and validated atomic models ready to deposit in EMDB or PDB. So we're doing this through a curated suite of external software programs, Relion and associated programs for the pre-processing and reconstruction steps, tools you're probably familiar with from the last release of CCP-EM for model building, refinement, and validation, and some new tools on top of that for capturing all the metadata that's produced during this process and managing the massive amounts of data you're producing. So all of these software programs have been chosen to work smoothly together, but at the same time, we're not going to limit what people's choices are. So there's a system for third-party plugins. So the whole thing is modular, and you can cassette in different pieces of software if you don't want to use the ones that we've chosen for various tasks. So the software release is a modular pipeline. It's built in kind of three distinct layers. The first is called CCP-EM Pipeliner. So this is a job runner. It takes your data, it makes calls to external pieces of software, runs them, and then manages all the data that comes back. You interact with the pipeliner through the pipeliner API. So this can be scripted from the bash shell or the command line, and scripted in Python as well to build workflows up. And finally, you can interact with it through our second piece of software today, which is called Doppio, which is a full-featured front-end GUI that can run in a web browser or on the desktop. So I'm just going to work backwards through these things, starting with the fun bit, the pretty pictures and clicky buttons. So Doppio is designed to be a user-friendly GUI. When you fire it up, you get your project page here, information about your project. On the left panel is kind of project-wide tasks, such as cleanups, generation of reports, which I'll talk a bit more about later in the talk. It can manage multiple projects. So you go up to this thing in the corner here, and you can pick one of your projects to switch to it. And you can also create a new project by entering a new directory. So if you enter a new directory, it'll create a Doppio project in that directory, or you can also enter the directory of an existing Relion project to import it and use it there. And both Pipeliner and Doppio are currently compatible, both forward and backward with Relion 4. So you can do a project in Relion and then use the Doppio GUI to view it and run additional jobs, or script it in the pipeliner and then go back to Relion. The only caveat being, if you run tasks that don't exist in Relion and Doppio, you're not going to be able to view them with the Relion GUI. So to run a new job in Doppio, you just go to the Jobs tab. You can see the list of all the different tasks that are available. Each task is then subdivided into individual one-function jobs. This list is quite long, so you can filter it by keyword to find specific job types if you want to use them. So when you pick a job, you click the job to go to the parameter entry page. So every parameter has a help, has information about it. Things that require files suggest appropriate file types for the entries to get you in the right way. You see here, this is some real-time validation occurring. Every field in the parameter entry is validated in real time to prevent you from launching a job that's going to immediately fail. And on the same note, a lot of these options are dynamic. So for example, here, when you turn off alignment, you see a lot of the features are grayed out. And again, this is to prevent people from having to enter parameters that aren't actually being used by this specific task. So you can click here to see this is the command that this is then going to execute when you run the job. And then you just hit run, and it goes. So Doppio can run the job on the local machine, or it can submit to a queue using a template-based queue submission system. If you've used Relion in the past, it's a similar system, although it's been expanded and made a bit more flexible to work with as many different varied queuing systems as possible. So once a job is run, we have tools for viewing the results. So if you go to this Jobs tab, this now shows all of the jobs that have been run in this project. The little functions for the job allow you to set its status, view it in the context of the whole project, use this graph. There's also a clone feature. So if you say clone a job, it gives you a new job parameters page that has all the parameters from that previous job filled in. So you could just tweak one if you wanted to. Every job then displays its results. So here's an example of automated 2D class selection in Relion. It shows the classes it picked and a sampling of the particles. Again, for 2D classes, you can just use 2D classes. For jobs that have three-dimensional outputs, we have a built-in 3D viewer. So here you can view this initial model. You can adjust the threshold and opacity and stuff to look at it. Every job will give you the full logs for the programs that it ran with a standard out and standard error. This IO tab shows every file that was an input or output from the job, and it allows you to then open them in external programs. So for example, a text star file you can open in a text editor, and molecular models and maps, you have a selection of external programs if you want to do more advanced things to them, like Coot, PyMol, Chimera, et cetera. So we've really gone to an effort to make the displays as nice and usable as possible. So for this example, I was scrolling this on my laptop, so it's a bit shaky. This is a mask, and you can see that what it shows is actually the mask overlaid over the model, the map that it's masking. Let's see here, this is, the model can also show atomic models. So this is a job that fetched an atomic model from the PDB. You can see the atomic model viewer works in the browser or the web or the desktop app. And then it can also display maps and models together. So this is an example of a refined model from RefMac that's now being displayed in the outputs. So these results outputs here are binned and optimized to run and load quickly. But if you want to actually look at the full resolution map, you can just go to the input output tab and open it in our viewer or use PyMol, Chimera, or any other program that's supported. It also has a file browser. So this allows you to do is browse the different files in your project by type. So if you wanted to say, find a specific density map, you could go down and pick that one. So all the files in the project are organized in a nodes system, which tells the pipeliner what type of files are appropriate for what kinds of jobs. And each of these has a built-in display type. So for example, if a file is text, it'll just give you a nice text view. There's a built-in PDF display as well, so things that produce PDF log files can be viewed in the browser. Like the jobs page, this is all searchable by keyword. So for example, here, this is all the files that were associated with CDF refinement and determination. And again, you can see the nice displays. And here's an example of some CTF refined particles. So I think it's quite obvious with all the tasks and jobs we have, it's going to get really complex really quickly. And to try to alleviate this, we've built in a themes system. So what this means is if you go to this little themes control here, you can choose a different theme. So here I'm going to go to the Relion single particle theme. And this gives you a nice orange version of Doppio. And now if you look at the job list, it has only the jobs for single particle processing in Relion, and they're in the specific order that users of the Relion GUI are used to seeing. We don't want to limit people in the theme, so you can always uncheck show jobs only from this theme to get back all the other jobs, but this kind of simplifies the view that the user has. So we currently have a Relion single particle theme, we have a Relion helical theme, and we have a model building theme with just the model building tools. And the way we envision this theme system being used is a facility manager will have Doppio on their system, and then they'll choose which pieces of external software they want to support on their system. And then you can have a custom theme that has your institution's logo and just the pieces of software that you support in whatever order you feel is appropriate. Along those same lines, if you wanted to, let's say, do a workshop, you could make a specific theme for that workshop with just the tasks that people need to be using in the right order. Or for a specific project, if you have a really defined workflow, you could, again, just have just the tasks you need in the order you want them in. Okay. The second big task in a pipelining system like this is tools for automating complex workflows. So this example here is a bash script of a on-the-fly pre-processing. So importing micrographs on the microscope, running motion core on them, and then determining the CTF with CTF find, and then just continuing to run this over and over again as new micrographs come off. So this is scripted in the bash shell through the pipeliner. It's very short and very simple. And here's the same thing scripted in Python. It's not very much code for a lot of functionality. I have two examples of more complex things. We're encouraging people to use the pipeliner to build their own applications. So the first is Rely on It. This was written by Dan Hatton at Diamond Light Source, who's going to speak next. This is a full on-the-fly pre-processing and evaluation program. Imports the micrographs, runs Motion Core, runs their in-house ice evaluation software called Icebreaker, does CTF determination, picks particles, extracts and batches them, generates an initial model and 2D and 3D classification. So Rely on It is interacted with through its own GUI, which allows parameter entry, and its results are viewed with their iSpy-B system, but the back end of this behind the scenes is all being run using the CCP-EM pipeliner. A second example here is script submission. This is a subset reconstruction program. So what this does is this was built as an example of how you can script the pipeliner. It's included with it. You take a refinement job, it then splits the particle set, shrinks each half set by a certain amount, recombines and re-refines, but using the existing angles, and then repeats this process, split, shrink, re-refine. And what you end up getting is multiple reconstructions with decreasing signal to noise. And this can be used in the same manner as the Rely on B-factor script that was included with the original Rely on to make a prediction about how much resolution you might gain by adding additional particles. Again, this is all scripted in the pipeliner, and it's there as an example showing how you can script very complex tasks using pipeliner. The third big thing we want to do with this package of software is provide tools for managing all the data you're producing. So if we step back and think, how do we describe a cryo-EM workflow? You keep a really, really good lab notebook, and then you refer back to your lab notebook and you write a wonderful methods section for your paper. You comb through all the logs of all the programs you ran to get all the information to build some sort of diagrammatic workflow. You probably have some summary tables that have summary data about your results. Then this is generally transcribed into entry forms for the databases by hand. And we've already talked a lot about machine learning. There's a lot more machine learning talk to come. And as it becomes more and more prominent, all of these workflows, published workflows and information in the databases is going to become prime material for training. So we really have an interest in making this as accurate and complete as possible. And there are lots of ways in this process that inaccuracies and incompleteness get introduced. You have to go through all of your individual log files from all your different programs, know the format of everyone, where to find every piece of information. It's a lot of work. And that generally leads to these database entries being less complete and less accurate than we would like them to be. So the pipeliner is providing tools to manage all the data from these complex workflows. So this here is an example of a reconstruction project in Rely on. The person went on a couple blind alleys, did some test jobs to establish their picking parameters, and ended up with about 4 different reconstructions. So the pipeliner can do is you tell it what the terminal job is, so the one you're finally happy with, and it traces the critical path, gives you back only the jobs that actually contributed data to that final job. And then we can interrogate this workflow now to produce all sorts of reports. So first, every job run in the pipeliner records a complete history of every operation that's performed. So you can go back and you can look, you can see when tasks were run and what commands were executed for each individual task. Second, every job defines a specific set of metadata that it returns. So that includes all of the running parameters, which are listed in this JSON file, and then a set of results parameters that are tailored to each specific job. And we've tried to make this as exhaustive as possible. So what this means is you can click on a terminal job in your project and generate a metadata report for a single job, an entire project, or upstream or downstream from any specific job. So this report is really designed to be as exhaustive as possible. Every job that was run, every parameter in every job, the versions of software that was used for every single thing, and then the specific results parameters for every job. And this metadata report also contains a graph of the pipeline itself showing the interconnectedness of the different jobs and how what files are passed from what job to each other. And finally, to give credit to all the developers who have helped you along the way, you can also, from any given job, generate a reference report. for a job or for an entire project. So this shows every piece of software that you've used, which jobs used that piece of software, and it's laid out in a JSON format that's ripe to be scraped by other scripts. So you could write a script that prepares your EndNote references directly from this. And all of this is really designed in the most basic universal way possible using just JSON files. So it should be easy to incorporate into LIMS systems or electronic notebooks or write your own scripts to use this data in however you want. So another task of the pipeliner is to preserve workflows. So again, if you give it a terminal job, it can produce a zip archive. The first type is a full archive. So this preserves the project's directory structure, all the input files you used, and all the results that were produced. And this is all packaged up in a nice zip archive, a single file preserving your entire workflow. The second archive is the simple archive. So this again is to preserve a workflow and repeat it if necessary. It preserves the project directory structure, all the input files, but instead of giving you all the results, it instead just gives you a script which allows you to rerun the entire project from start to finish when you input the raw data. So this preserves an entire project workflow exactly as it was done in a file that's only a couple hundred KB. And this can also be used where if you have a very similar workflow, like doing the same protein structure over and over again with different ligands, you could do it once, make a simple archive, and then use that script to process a different data set using the exact same workflow. Okay, so we're really happy to announce that today is the official beta release of both Doppio and the CCP-EM pipeliner. So you can go to CCP-EM website and download them, use them. CCP-EM pipeliner is completely open source, so please use it to build other applications, build on it, contribute. And Doppio is under the CCP-EM license, so of course it's completely free for all academic use. And at the end, I just want to talk quickly about some of the upcoming features we have for the pipeliner. So the first is the work of Rangana, who's the newest member of CCP-EM, and he is building a full tomography data processing pipeline in the same manner that Pipeliner and Doppio currently handle signal particle. So this will do tomogram reconstruction and subtomogram averaging. You can see kind of the programs that we're incorporating into this workflow now. But like the pipeliner, again, it's going to be a modular workflow, so you can do specific steps with other pieces of software if you want to incorporate them. And this is work done by Rangana, and it's in collaboration with Zach Freiberg at University of Pittsburgh. And the last, and I think most requested feature is automated deposition preparation. So the pipeliner already has the feature to run pre-deposition validation. So these are the same validation reports that you'll get when you submit to the PDB and EMDB. So you can run them in the pipeliner before you actually are ready to submit your data to check that everything passes validation as you expect. So this is the EMDB validation, and this here is the PDB validation with all your mole probity scores and everything done for you with a simple one job. So second is automated deposition to Empire. So you can launch this from any job that produced movies, micrographs, or particles. It prepares an upload directory. It packages everything up. It makes sure all the naming conventions are correct. And then it creates a deposition data file, which you can use in conjunction with Empire Depositor script from EBI to fully automatedly deposit into Empire. And this feature is currently built and functional, and we're testing it, and will be included in an upcoming release of Pipeliner soon. And a bit further down the road is tools for deposition to both EMDB and PDB. So these will be launched from either a refined map or a model, and produce a data file, which you'll be able to upload. And hopefully when you then start your deposition, a lot of the fields will be pre-filled. So obviously there's a lot of information in an EMDB or PDB deposition that's not going to be captured in the Pipeliner, so they can't fully automate this process. But at least here, all of the information you can pull will be transcribed and it'll be completely accurate and as complete as possible. Okay, so with that, encourage everyone to download the Pipeliner, use it, build things with it, download Doppio, use it to process data. Speak to us if you want, if you're a developer and you're interested in adding your software to CCP-EM Pipeliner. We're happy to teach you how to write job tasks to include yourself. And just thanks to everyone who's involved in this project. This is done in collaboration with Shore Shears Lab and supported from Global Phasing by Jared Bracon. Everyone at CCP-EM and CCP4, the EBI team are helping us sort out depositions. All of our commercial license holders who, again, support this work, and all of the developers whose software is getting included into the pipeliner. So with that, thanks for your attention, and I'm happy to take any questions.